Thank you, folks, for joining in. Good afternoon, everyone. So today the topic of our session would be around pentesting Android application. We'll try to keep it simple and try to pause me if my any terms that I use or any words are confusing or am I going too fast or something. Feel free to always stop me. Okay, we'll get started. Okay. So before we start, what is pen testing? So any application that we have, we might have heard this term a lot. What is pen testing? So primary objective of pen testing or penetration testing is to identify areas of possible vulnerabilities in your application. Take a look at this example photo. So this is to identify where a crack is there in your wall. Similarly, identifying where there is a weaker spot or a spot where it could be exploitable to gain more information about the application, that weaker spot, identifying that is pen testing. Okay, so today we are going to use a tool for pen testing hands-on. So the tool is AndroGoat. What is AndroGoat? AndroGoat is a purposely developed vulnerable application, which means purposely an application with a lot of areas to exploit, with a lot of cracks in it. So that is a purposely developed vulnerable application, which will help developers or tech people or security enthusiasts to get to know about possible areas of exploitation and to also to avoid it. So that is a purpose of this application. We'll be using this application to cover like a few of the vulnerabilities, common vulnerabilities in Android. And one additional information on that is this application is the one and only application that is developed using Kotlin, which is a new Android development language. And this is developed by one of our thought workers, Satish Patnaik. Okay. And so there are many vulnerabilities that we have in Android, and there are few vulnerabilities which are common to both web application as well as Android application. And I have listed out few common Android vulnerabilities, some of which include unprotected Android components, insecure data storage, input validation, SQL injection, which might be common for both web application as well as an Android application, and hard-coded issues. We'll look into what these vulnerabilities are, why these can happen, and how to figure out where this exploitation is. We'll look those in details. So these are some of the common vulnerabilities. Okay, we have a question in chat. Is the AndroGoat code base public? Yes, it is public. I can show you that. Yes, this is an open source AndroGoat code base. We can access it. Thank you, Karim, for the question. Feel free to pause me as well if you folks have any questions. Okay. We'll look into some of the common Android vulnerabilities and how to exploit them. And we'll also see how we can avoid them. Like as a developer, you wanted to avoid them. And as a security enthusiast, you wanted to understand where are the areas, where are the weaker areas that you could exploit. So we'll look into all of those. We'll see some examples. Considering the timing constraints, maybe we'll see 4 or 5 vulnerabilities in detail and see how we can exploit and also how we can avoid those. Okay, so what do we need to start with pen testing Android application? So we need a pretty much simple setup because Android Studio has many built-in features. Android Studio has a lot of features that it provides automatically to us, including the emulator setup and the platform tools. So the primary tool we use here is Android Studio. We also need the Android platform tools, and if you have a rooted Android phone, a rooted Android phone on, or a normal emulator should also work. Why we need rooted Android phone is because, okay, rooting a phone is primarily getting elevated access, to see the internal contents of any application. So that is why we needed a rooted Android phone. In our case today, for the demo purposes and hands-on, we'll be using an emulator itself. That should work fine. Okay, so we'll any questions so far, folks, before we jump into. Okay. Okay, we'll see some vulnerabilities in detail, how they are happening and how to avoid them as well. How to exploit first, and then how to avoid also. So first, we'll see unprotected Android components. In our exploitation, we'll use service. So first, let's try to understand what is an Android component. Android component is primarily the building blocks of any Android application. For example, let's take your WhatsApp. When you open your WhatsApp, you will see your chat screen. It is a activity, which is an Android component. And let's say you are in a call with your, family or your friends, and it is running in the background. It is an Android service. That is an Android component. So these are kind of like the building blocks of your Android application. So, so in our example, what we could do is, okay, we understood what an Android component. Let's try to understand what does an unprotected Android component mean. When we say unprotected Android component, it means that that activity or service or any other Android component is exposed to the outside world, which means it is exposed to beyond its boundaries for other Android applications to access it. You might have a question why this is happening, or why do we need to primarily expose your Android component? This is a feature that Android provides where in specific cases where you wanted to communicate from one application to another application, you have to expose some of the activities or services. This is an intended purpose, but if you are using it without any protection, proper protection for it, it might be exploited. One example of one service is, playing your favorite music in the background using any of the music player application is an example of a service running in background. Let's try to, exploit this in our vulnerable application. I have already installed this vulnerable application AndroGoat in my emulator. So this is my setup. This is my, Android Studio and emulator running. I have already, installed the AndroGoat application. Okay, so let's try to see, go to unprotected Android components and see. So what they are saying to set a pin, let's say I'll give 1, 2, 3, 4, and I'll verify the pin. Okay. So after I set a pin, the proper flow of the application is to download the invoice only when you set and enter the proper pin, correct? So that is the proper flow of this application. But what if the service is exposed outside? What if without entering the pin, I am able to download this invoice? That is an unintended behavior which I am trying to exploit. Let me try to do that. So to do that, what I'll do, I have this, APK Android application with me. What I'll do, I'll go to build, analyze APK. I'll take that APK. Okay. So this is a feature to, reverse engineer the contents of your application and see what is inside your application. So that is this feature that Android Studio provides. So what I'll do is I'll go and see the contents of this Android manifest.xml. if I look into these contents, when I search for a keyword exported, which means it is exposed outside the boundary of its application and it can be exported. This is the pathway that I was talking about. This is how this can open the gates to outside its scope of within that application. So I'll check for whether there are any exported services available. Yes, there is one service which is exported, and that is download invoice service. So let me try to exploit this service. Let me try to, without entering the pin, let me try to download the invoice. So now I'll clear all the contents. I'll go back. I'm just inside this application. I am not entering any pin. I am not verifying the pin, which is the intended purpose of this service. What I'll do, if you are already aware of Android platform tools, so we have this ADB, which is Android Debug Bridge, which is kind of like the set of commands that we use to communicate with the connected Android device. In our case, the emulator. So this is how we communicate. The command line communication with the Android phone or emulator happens. So I'll just check whether there are any devices connected. Yes, this emulator is connected. What I'll do, I'll just, sorry. What I'll do, I'll run a command which says, go inside this ADB shell and start a service. What service? I'll mention the name of that service. This is the package name of this application, os.sat.androidgoat. This is the package name of this application. And then I'm saying inside this application, run this service. That's all I'm saying this. When I do this, what happens is you can see the invoice is getting downloaded automatically. I haven't entered the pin. I haven't gone inside it. It automatically downloads. This is what happens when you unintentionally expose your services or activities outside. You should expose it securely only when you need it to be exposed. Any doubts or questions so far? Okay.
I have one doubt.
Yes.
Uh, the application is in your background, right? So it is active. Will it work like whatever you did, right? This shell, will it work if it is killed or something?
Okay, good question. Let's try that out. Okay, that's a great question. Okay, I have killed all the applications in my recent applications. Okay, now what I'll do, I'll run the same command. Let's see what happens. It downloads. Why? Because this command that I run, I am saying start a service in this application and this service. So what it will do is, even if the application is open or even if it is closed, it will just check first. It's kind of like searching for an address. It will just go and check whether this application package name is present in your mobile phone or emulator. It will just check. So it will check for this application. We have this AndroGoat application installed. This is the package name for that application. So yes, this application exists. And then it goes and sees whether this service exists inside this package name. If yes, it will start the service. That's it. No matter whether your application is opened or closed, no matter that, as long as this address, as long as ADB is able to find this address, it should be able to execute. Okay. So what happens if I give a wrong, let's say I just give a wrong, service name. It'll just go and search for that address. And then it'll say, hey, I couldn't find that address. That's it, simple. So no matter where your application is opened or closed or running in background, As long as ADB is able to find that address, it will execute it. Okay. Cool. Thank you for that question. Okay. Hope that clarifies.
Yes.
Okay, cool. Thank you. Okay. So to avoid this situation, right, what we primarily do is we'll set some, protection, and we'll try to avoid this exported, setting this exported to true as much as possible. You set this to true only when needed, only when you wanted explicit communication of your service or activity or any other Android component with outside application. Only when you wanted that specific functionality, only when you set it to true. Otherwise, just set it to false. Or if even if you remove this line, what happens is it'll by default take it as false. Okay. Okay. Any questions so far with this vulnerability? Cool. Okay. Let's move on to the second vulnerability. Okay. Second common vulnerability that we're going to discuss is about insecure data storage in shared prefs. Let's try to understand what shared prefs actually mean. Shared prefs are a way to store data, way to cache your data in your internal storage in key value pairs for insensitive data. I'll try to quote an example. For example, if you look at this photo, let's say you logged into any of your application, and then let's say whenever you open that application, you wanted the screen to look like good morning and your name. So if that is the functionality, what the developer of that application would do is primarily, first time when you log in, they'll get your username, and then they'll save that username into shared prefs, so that whenever you come back to that application and open it, it will say good morning and the username. We'll store, key value pairs in an XML file, which are insensitive. This is the keyword here. So what if I store sensitive data in a shared prefs? That's where, pen testers or, hacking, that's where the doors to hacking opens up. So let's try to figure out if there are any sensitive contents stored in shared prefs in this application. Let's try to figure that out. We'll go to this application. Okay. For example, I'll just give the username and password as password, and then I'll give save. It just showed the message data save. Okay. So what I'll do, so in Android Studio, there is an option, device file explorer, where you can select the device that is connected to, and you can see the internal contents of the entire device. So what I'll do, so as I mentioned, this data shared prefs are stored in your application's internal storage, right? So I need to figure out where the application data sits in this entire file explorer. So I'll go inside data. Inside data, there will be another data folder where you will have internal, storage of all the different applications installed in this emulator. For example, these are default applications, Chrome, YouTube, all the default applications. What we wanted is our application, and what is our application name? ovasp.sat.agoat. Let's try to see if that application sits here. So if you can see, this application data is here. And if I try to open the shared prefs, there is a folder which gets created automatically whenever you try to save a, shared prefs. It'll create a folder, shared prefs. And inside that, I see two XML files where I'll try to open the users.xml file. If you see here, the username and password that I have given now is already present. Username, storing the username inside that XML file is fine, but passwords should not be stored as a shared prefs. Let's say, I'll try to give another username. I'll give random, just give random pass. Okay, so I'll try to reload. I'll try to navigate to data folder. Inside data folder, there should be another data folder inside which we'll have all the applications listed. We'll select our application, go to shared prefs, open user, and you can see it's storing the new username that I have given with the password that I have given. This is the vulnerability I was talking about. Whenever you try to store sensitive information in your XML file, this could be exploited by anyone. This is the exploitation. Why some developers tend to do that is because storing data in shared prefs is easy to retrieve, easy to store. It is easy. So that is the primary reason why they are doing this. But any sensitive data should never be stored in shared prefs. And let's also see how to secure this. One additional way of securing it is there is one other concept called encrypted shared prefs in Android, which we could use to save, so that the data will be stored in an encrypted storage. So that is one additional way to secure the application. When we just plainly store it in XML file, this could be exploited. Any questions on this?
Maybe a small question about the encryption. So we can store the value encrypted and store the key also in the shared preferences, or the key would be somewhere else?
Okay, so when we use encrypted shared preference, what happens is you will have a separate file path that you need to mention, and then you will store it in that file, which will be encrypted file. So you can't, so directly I went and so here does it answer your question?
Sorry, it got cut up. Can you repeat, please?
Okay, so what I was saying is when you use encrypted shared preference, what happens is you don't directly save it in this XML file. You will mention a separate file path and then you store the information there. And the advantage of doing that is I can't directly access that file inside the shared prefs folder. So here I just, when you save it in normal shared prefs, I just open this XML file and you have all the information. When you use encrypted shared prefs, you can't access that file at all.
Okay, got it. Thank you.
Okay, cool. Okay.
Hi, I got one more question.
Yes.
In your storage, so yeah, I understand that, like, if you save it in, like, clear text or as a shared pref, sensitive data is not advisable. But can you explain how can the exploit happen? Like, how can, let's say, a malicious application or a malware that runs, how can it access the path?
No, when we use encrypted shared prefs, we can't. That's what
not encrypted shared pref, but if you use just normal, safety normal shared prefs, how can you exploit that happen?
Okay, that's what I was mentioning now. So when you use shared prefs, what happens is in your application's internal storage, it creates a separate folder shared prefs and it automatically puts all the data that you have input into a XML file. And you can just, so here I'm using Android Studio. If you're comfortable with, like Bash or Ubuntu kind of setup in terminal, you can just enter the ADB shell and just navigate to this shared prefs folder, and then you can access this, read this XML file directly. You can, get the password. So any sensitive data that you store, it's just, written into this XML file. You can access the password. You can see, right? The password that I have entered is random, and it has, I'm able to read this password.
Yeah, I mean, that's if I'm running the application. Let's say I'm trying to access, so I'm a malicious actor. I install something on your phone. How can I access that shared path in a different application? Because Android also does have certain controls for applications in terms of accessing different sandboxes. So how does that actually happen in the real world? Not like if I have the application on my phone and try to test it, but
right. So to do that, what we could do is we could design a malicious application where what we could do is let's say like on button click or on opening that application, we'll run ADB commands which will retrieve this information. ADB command, when I mean by ADB command, you enter the ADB shell, and that's why I mentioned when we go with the terminal root, it is always better to have a rooted phone. That's why I mentioned that rooted phone. If you have a rooted phone, in that case, what will happen is you will have access and reading of all the files easier for you to navigate. In your case, let's try to achieve what you were trying to say. Let's try to navigate to this folder, cd data and shared prefs, and I went inside this folder. Okay, so what I'm saying is, if in the real world, if you wanted to get hold of this information, get hold of this XML file, means what you need to do is you inject an malicious application, either opening that application or maybe installing that application itself. Run this command to navigate inside that shared prefs folder, and then retrieve this XML file, and maybe like send it to your location, or send it to maybe your email ID or something. So
I think one of the other things here is that you mentioned the sandbox. Shared prefs are sometimes accessible by other applications. They're not necessarily limited to a sandbox. There are certain settings you can put on shared prefs for one app to allow it to be read by others. So if it's not locked down, then yeah, shared prefs are intended to be things that are not supposed to be secret.
Exactly. Yes, that's why I mentioned insensitive information should not be stored in shared prefs. Shared prefs are primarily meant to store any information that you wanted to, wanted your application to easily retrieve whenever needed. It should never store any insensitive information. Sorry, it should never store any sensitive information. That's correct. That's the purpose. But if you lock it down in the settings of the application, then no app would be able to access it. Mohammed, can you, when you say lock it down?
No, because just like I think Lily said, you can lock it down just for the application, or open it up for all applications. So I'm just asking if we can actually lock it down for one application, then this might make the risk smaller, right?
So in Like when you say lock it down, can you elaborate that, please? When you say lock it down, what do you mean by that?
Yeah, I'm not sure. I was just following like what I think what Lady said. Just lock it down. At least that's what I understood, but maybe I misunderstood.
Okay. Share. So to reiterate. Sorry. Go ahead.
Sorry, I just realized what you're saying. Yeah, it would reduce the risk if you set certain flags, if you took care to do that. But given that it is not designed to be a storage that is, contains sensitive information, it's not expected that it would have such robust protections. So, it can reduce the risk, but ideally, if you're going to go to the effort of making sure that your parameters are set correctly to keep all of that information as close to the app as you can, might as well use the encrypted shared prefs.
Exactly. That's right. It's always a good practice to not have any sensitive information. And as mentioned, one additional level is to use encrypted shared prefs, even for the insensitive data. That is one additional layer of protection. Okay. Cool. Okay. Moving on to the next vulnerability. Most of you might have heard about this input validation and SQL injection in web application exploits as well. Okay, so what is SQL injection and why do we need input validation? So SQL injection is primarily I'll try to give an example. Like whenever I try to get a username and I wanted to username, if I wanted to query in the table to fetch the address of that user, what I'll do, I'll just select the address from user and the username that I fetched from the user. So what happens if I directly what happens is, let me maybe write it down here. So what happens if you say select address from let's consider the table's name as users, and let's say I get the username from my text field from the user. What happens is, where if I say user.name equals, I'll say the input from this field. I'm just not writing syntactically correct statement here. I'm just trying to put how it might look like. Okay, so what happens is, if you have used in your code something like this, if without sanitizing the input, without validating if the input is correct or not, if you try to directly use it in the query, what could happen is, let's say in the input field, I go and put a double quotes, and if I give semicolon, what happens is it will not consider these parts. This is one downside of query languages. What happens is it will just take the input string and then just apply it here. Which means the remaining part after this input, whatever the condition that you mentioned, will be skipped. So that is one problem or downside which will happen if you don't sanitize your inputs. So that is why sanitizing your inputs and input validation is very important whenever, especially when you're dealing with calls to the databases and fetching some information. Okay, so let's try to exploit one of the input validations which are not properly built in the application. I'll go to input validations. What I'll do, as I mentioned, In addition to sanitation your inputs, please always use parameters. Plus one, Jonathan. Thanks for adding that. Please always use parameters in your queries instead of just concatenating.
Yes, sorry, I'm a little bit a geek of SQL.
Yes. So let's try to try to see what happens if I just give user here and verify user not found. Let's try what I told here, just the double quotes and semicolon, and see what happens here. What happens? It's saying user not found. What if I try the single quotes and semicolon? So not found. What if I don't give the semicolon? I get a different error. If you can see, it says error occurred if I just give the single quotes alone. And if I say verify, you can note then error occurred unrecognized token, which indicates it's directly getting, concatenated in any of the, SQL queries. Because for all the other things that I brute forced and tried, it just gave user not found. But when I tried with the single quotes, what it says is, it gives me a different error, which is one way of identifying that, like in the process of pen testing, you are on the right path. So now I'm on the right path. What I'll do, I'll try to, append maybe where username, I'll just close that username and say 1 equals 1. If I say 1 equals 1, the condition will always be true and it will always return me the entire list of data that is stored. Okay, let's try with semicolon. And here it is. You can see when I give this, bypassed the original query, what happened is it gave me the list of all the users with the password. Probably the don't folks. Okay, we'll move on to the next one. Okay. Okay, the next vulnerability that we could do is, this is one simple but common vulnerability, which is hard-coded issues. In this way, the query is totally saved. Thanks, Jonathan, for adding it. Cool. So hard-code issues is one common vulnerability, but it is fairly straightforward where, if you try to hard code strings or, some information which you think might be less important, but could be exploited. So one way to avoid this is fairly straightforward. Just try to always avoid hard coding any strings or any data. And that is the prevention for this issue, but it is still common vulnerability. Let's try to see if we could exploit some in this application. So what happens is, okay, so let's try to, so the activity here is that enter promo code to get product for below 50. Okay, so what I'll do, as I did earlier, what I'll do, I'll try to analyze the APK to see if there are any hard-coded, strings or any information available from the APK. I'll again do the same steps. I'll go to build and analyze APK. I'll upload the same APK. And what I'll do, and if you see, I'll go inside OWASP set. So this is our application. And inside that, if I go to this hardcode activity. So in our case, in this case, I know where to find the root cause, but in a real world pen testing, you need to try spending some time in understanding probably each and every class or activity in that application. So in our case, we know where this might be there. So I go to this activity. So there is an option to show bytecode, which is nothing but the application APK built is primarily the code that the developer had written. What this show bytecode will do is it will just reverse engineer the original code and try to give us as much information as possible. So I'll try to read through the bytecode and see if there are any, hard-coded values for me to exploit. I'll see if there are any strings. Saved instance state. If you had worked in Android previously, you might have noted this. These are all internal to, like Android. So this is the button, verify button that they have. This is the price value. This is the promo code value. And this is something different. This is the promo code. Let's see if this value helps. This is some unusual string, which is not internal to Android or which is not any button value or something. It is something strange. Let's see if this value helps. Let's try to enter the promo code here. And if you can see, this has applied and the price has gone to 0. So in real world applications, if you, like if the developer thought it will be easy if he or she could, just hard code and equate the value entered and check for that condition, then that could be actually exploited like this. And then, we could get that exploited and get that thing for free in this case. Okay. Any questions on this one? This is fairly straightforward. Okay. We'll move on to the next one. Okay. There is one other common vulnerability.
Maybe
but-
a small question, Reghill, I'm sorry.
Yes,
About,
yes.
about the APK. So basically the APK of any Android application can be, it's a binary in the end, so you can look at the code, right? There's no, like for example, is when you do your app with the like the tools like a React Native or something like that, is it then easier? You would find the code easier, or this doesn't have a...
So React Native, like at the end, every like framework or tool that you use, it'll bundle up things and convert it into a binary, either APK or kind of like an AAR file or something. So when you reverse engineer it, it will always try to fetch the bytecode and give it to you. One way to avoid, try to I would not say avoid, I would say try to limit this reverse engineering is to do a process called obfuscation. Obfuscation is a process where if you put that obfuscation into place, it'll what it'll do is it'll act as a guard and it'll try to not give you more information when you try to reverse engineer it. So that is one process that you could add on top of your development practice. So it is always possible to reverse engineer, but if you put that obfuscation process in place and rules for it, it will try to give less options or less things to see from reverse engineering.
Perfect, thank you.
Cool.
Can I add something to that?
Yes, Lily, go ahead.
I would also recommend that you do, when you're thinking about the security of your application, just assume that the end user will be able to read all of the application Even if it is obfuscated, somebody really dedicated. I mean, the application has to work. You know, at the end of the day, it has to perform and function. And so somebody, you know, who's dedicated could still piece it together. There are also tools you can get where you can just grab the APK and drop it in, and it will tell you, it will highlight all of the problems in the manifest file and show you all of the strings that are embedded in the bytecode and decompile it for you and make it human readable. So the best thing is generally to treat anything that goes into the binary as something that an end user can see.
Thanks, Lily, for adding that. Yes, perfectly. That's so true. Like, it's always possible to, reverse engineer. So, okay. Any other points or questions before we move on to the next one? Okay, cool. Okay, so the next one is, this is one other common vulnerability in Android, but this is also fairly straightforward, which is about insecure logging. When I mean by insecure logging, as developers, what we do for debugging purposes is that we try to add logs. Like whenever any unexpected event or error or exception happens, we'll just try to print the log. So what happens is, what if for my debugging purposes, I just added, some sensitive information like, username and password in the stack trace. So that is, all those comprise the insecure logging. One other example of insecure logging is printing the, like entire stack trace of it. So that is one other. So if you try to print the entire stack trace, what will happen is the hacker could try to, go deeper down to see where it might happen and try to, hit that particular point hard to see if there are any more exploits available. So it's always a good practice to not print any sensitive information or the entire stack trace whenever we try to, debug and bundle the application. So that is one. It is fairly straightforward, but it is one of the common Android vulnerabilities out there. Let's try to exploit that as well. Okay. So what I'll do, I needed the logs to be tracked for me to fetch if there are any sensitive information or stack trace available. So what I'll do, I'll go to logcat. So logcat is primarily prints all the logs happening in your particular device. In this case, the emulator. It will print all the stack traces. So what I did is, I just added a filter to just show me only the error logs. Okay, I'll just clear it now. I'll just try to enter a username and password. I'll just create chill, and then I'll give the password as random password. Okay, and then if I click verify, what happens is, in the application you can see there is an error occurred, and whenever any error occurred, as a developer, the common practice is to try to print the logs so that we can debug it into later. So what happened here is, one not so great practice here is that the developer tried to say that there is an error, but he or she also added username and password. You can see this is the username and this is the password. The entire password that I have entered is printed in the log trace. So it is always a good practice to not include any sensitive information, as well as to not print any stack trace in the error messages. So this is fairly straightforward, but this is one of the common mistakes in the Android world, and it is one of the common vulnerabilities out there. So any questions on this one? Okay, cool. Okay, we are right on time. Okay, there are many other, vulnerabilities out there as well. We have covered, like around 5 common vulnerabilities out there in Android. I also just wanted to mention more about OWASP. Some of you might be already aware of what OWASP is. OWASP is a non-profit organization which the primary aim of that organization is to, build security awareness, build a, checklist for the developers and development team, and put security practices in place. That is their primary objective that they are trying to achieve. And what they do is every year they review the attacks and exploits happening in Android applications, web applications, and application in the technology world, and they'll try to collate and see which are the common vulnerabilities across different domains. For example, in web application, if SQL injection is the most common vulnerability happening in the year 2023, they'll collect those details and put it in the top 10 list of web applications. And similarly, in our case for Android, they have a separate list of top 10 mobile vulnerabilities, which they try to maintain every year. So if you could see, I'll just show that maybe. So this is their website, if you could see. So they try to, update this list, top 10 list every now and then. They'll come up with top 10 vulnerabilities, and out of the 5 that we have discussed, 2 are already in the draft list of 2023 and 3 are in the, consideration list, which is not yet placed in the 10, but it's still in the consideration list, which is, so that's why, so these 5 vulnerabilities that we try to cover are most common and latest, that is trying to be in the top list of 2023. That's why we try to cover, even the simpler ones. So it's always a good practice, like if you are dealing with mobile application development or web application development, try to keep this as a, like kind of like a checklist to see if we have remediations or prevention measures in place to avoid these top 10, vulnerabilities. So the 5, as I mentioned, all the 5 things that we discussed are in the either in the draft list or in the consideration list of as of 2023. Okay.